Okay, so we're doing chapter 26 from my book, Overcoming Digital SAT Math, this chapter covers exponential and linear growth and decay. So, and that also includes half-life. So if you have a copy of this, for the best results, I recommend that you do the problems timed 1 minute per question first on your own before attempting corrections, also on your own, and then referencing this video for explanations on anything that you are just stuck on and can't figure out how to correct on your own. Also pay attention to the description of this video. Over time, I'm probably going to be adding links to other videos I do in the future that you might find helpful as a lesson or something like that before attempting these problems, or updates, extra tips, things like that. So pause to read number 1 if you haven't already. So what we want to do here is we want to say, okay, what's the initial that we're starting with? So we're starting with 250 as our initial. And then we're going to be multiplying by how it's changing. So it's doubling each time. So that means we're multiplying by 2 each time. And then the exponent is going to be, okay, how many times are you going to have to multiply by 2 in this scenario? Well, it says that it doubles every 3 hours, and we want to know how many bacteria there will be after 18 hours. So it's not going to be 18 as our exponent. We have to divide 18 into groups of 3, because it's only going to be every 3 hours that we need to double over the course of those 18 hours. So 18 divided by 3 is 6. So our exponent here should be 6. And when you do that, you get C, 16,000. Okay, pause to read number 2 if you haven't already. So for this problem, you're going to want to have, for T, you're going to want to plug in 1 hour. And then make sure that the population P does in fact equal 750. So look at this and ask yourself, okay, and it has to be exponential. That's an important part too. So first I'm going to ask myself, which of these are exponential? So based off of that, I'm looking at B and C now. So I have to determine, okay, when I plug in 1 for T, in answer choice B, do I get 750? Well, that would just be 500 times 1.5, which does in fact give you 750. So the answer is B. Okay, pause to read number 3 if you haven't already. So right off the bat, I know that this is going to be increasing because the number of visitors is increasing. It's doubling, so it's becoming more over time. It doubles each time. So I can eliminate all the decreasing options. I also know, since they use the term doubled, that this is going to be an exponential function. If it were a linear function, it would say it would be increasing at maybe 2 visitors per day instead of doubling. If we have to multiply by something each certain time interval, it says for each day for the next 6 days it's going to double, then that means that we're multiplying by 2 each time, meaning we have an exponential function that is increasing, so the answer is D. Okay, pause to read number 4 if you haven't already. So we're looking at time intervals of 5 years here. So from 2020 to 2025, that's 5 years that have passed. Let's see how the population changes. Well, it goes from 50,000 to 70,000, so it's going up by 20,000. And I know that it's just going to be plus or minus something, in this case plus, because it's growing. And I know that because it says growing linearly, so I know right away that means I have to add or subtract something. If it's growing, I add to make it bigger. Exponential would mean that I have to multiply by something. So I'm going to say that I'm adding 20,000 every 5 years. So to get from 2025 to 2030, that's another 5 years, meaning I have to add another 20,000. So 70,000 plus 20,000 is going to give me 90,000. So the answer would be B. Okay, pause to read number 5 if you haven't already. So I know that this is not a linear function. This is exponential because it says that it increased by 60% annually. If I am increasing by 60% annually, that means I already have 100%. So 100% plus 60% increase is going to be 160% that I'm finding of whatever the current value is each time. So I'm really talking about 160%. So if I'm thinking in terms of an exponential function, I could say, okay, the initial value is going to be x, then I'm multiplying by the 160% as a decimal, because I need to find out what 160% of the current value is each time. So that would just be 1.6, because I just have to move the decimal 2 to the left right there. And then my exponent is going to be the time. So we're multiplying by 1.6 to get 160% of the current value. We're doing that annually, meaning every single year. So the exponent here has to be in years. Now, if we're talking about a 4-year span, that means my exponent here has to be 4. Because we're talking about the specific scenario where it's been 4 years and then the whole function is going to equal 8,192. So we want to solve for x, we have to get it by itself, meaning we have to divide by whatever 1.6 to the 4th is. So it would look like that. And when I do that, I get x is equal to 1,250. Okay, pause to read number 6 if you haven't already. So for this problem, I'm trying to find out what x is. Now you have to be careful, this isn't a typo. X is supposed to be there. It's just we have to use the table to plug in values for t and f of t and then solve for x. And the corresponding 532, then 2 over 2 is just 1, so you only have x to the first power, so you don't have to worry about like squaring or anything like that. So now all I have to do is divide by 700 on each side to get x by itself. And that would just equal 0.76. You don't even have to round or anything. I kind of just put that extra part to trick you to think that you got the wrong answer. Because sometimes I'll do that. But you could also put this in a fraction format. Like you could just simplify this if you want. But again, like why would you do that? It's like so much easier to just do 0.76. But if you want to simplify it, I mean, I'm going to just make my life easier and say 0.76 is the same thing as 76 over 100, but you can do the whole simplifying from this part if you want. It's just like, again, why would you do that to yourself? So I see they're both divisible by 4, so I'm going to divide by 4 on top and bottom, and that would give me 19/25. Okay, pause to read number 7 if you haven't already. So we're increasing by $50 each month. We're just adding that on each month. We're not multiplying the current value, which would change over time, by a certain number or anything like that. It's just adding a certain amount each month. So we know it's definitely increasing and it's going to be increasing linear. So that would be A. Okay, pause to read number 8 if you haven't already. So this is an exponential situation that we have here. Exponential growth, because you're earning 5% interest per year. So we would start with the initial amount, 250, and then in parentheses, you're going to have what the rate of growth is. So it would be like you already have 100% of something, it's growing by 5%, so we're really talking about 105% of whatever the current value is. So 105% as a decimal is just 1.05, and then we would raise it to whatever the time is in terms of like how many times do we have to multiply 1.05 by 1.05 to get to whatever we're being asked. In this case, it would be 5 years. Now, if they said that they did it every 5 years, how much would it be after 5 years? Then it would be just to the first power, because then the times that we would have to multiply by 1.05 would just be 1. So that's why I'm hesitant to always say like we raise it to the time, because that's not super accurate. It's not always going to work for you like the time that they say in the problem exactly. So like in this case it does, but just be aware of that. So I'm raising it to the 5th power because I have to multiply 1 time each year for 5 years by 1.05. So that would just be answer choice D. Okay, pause to read number 9 if you haven't already. So literally all you have to do in this problem is just plug in for n for the 2 different scenarios. And find the difference. So I would say like n is 5, and then I have to do the same exact expression and subtract it when n is 3. So let me show you how that looks. So this is how it would look initially, and then I'm going to plug in the n's that I just talked about. So I just plugged in 5 and 3 where the n's are supposed to go for the two different situations, and then I just need to subtract them to find the difference. Now you'll notice in the answer choices, we don't have anything that looks exactly like that. See? None of that is in the answer choices, but we have that exact expression just manipulated in a different way. So let's think, how can we manipulate what we already have to look like one of these answer choices? And as a reminder, this is the expression. So I see a greatest common factor of 3,000 that I can take out. And when I do that, it looks like this, which happens to be answer choice C. So that is your answer. Okay, pause for read number 10 if you haven't already. So this is an exponential function where we always just start with the initial 5,000. And then what goes in your parentheses that you're multiplying by each time would be 110%, which as a decimal would be 1.1. Because think about it, if it's increasing annually by 10%, you already have 100%. So increasing by 10% is 110%. So you have to multiply by 1.1 3 different times because we're talking about 3 years after she purchased it. So it has to be to the third power so that we multiply by that 3 different times. We also know that this has to be equal to 5,000k. So let's do that. So this is what I get, and now I just need to solve for k. Well, automatically, I can cancel out 5,000 on each side. So I'm going to get that 1.1 to the third is equal to k. So let's do 1.1 to the third power in our calculator. And that would give you 1.331. And that has 5 characters, including the decimal point, so we're all good there. Okay, pause for number 11 if you haven't already. So let's write out the situation for Bank A and for Bank B for the amount of money you'll have after those 4 years. Now, this is, again, going to be an exponential function. So we have to start with our initial, which is the initial deposit of 1,500. And then in parentheses, we're going to multiply by the by what the percent is as a decimal. That would be considered the rate of growth. So instead of saying, okay, it's going to increase by 2% annually for Bank A, we have to think, oh, we already have 100%. So 100% increasing 2% would be 102%. So we're really multiplying by 102% as a decimal, which would be 1.02. And same thing for B, but they offer a 3% rate. So it would be 103%, which is just 1.03 as a decimal. And then we have to think, okay, that's happening annually, that we have to multiply by that. So if it's happening over 4 years, that means we have to multiply by that 4 different times in each of these scenarios. So now we have what can give us the amount that they'll have in Bank A and Bank B after those 4 years. To find out how much more money they'll have in Bank B, we have to find the difference between these. So we need to subtract them. So this is what you would do. And then you're going to get your answer, which is D, 64.61 or $64.61. Okay, pause read number 12 if you haven't already. So we want exponential growth. So that means that we have to be multiplying by something, multiplying the current value by something each year or whatever the time interval is. So right away I see added for A, so that's out of the question. And for B, I see added again, like 10% of the original deposit. And while you would have to multiply to add on the 10%, you're still essentially adding the same amount because it's based off of the original deposit and not the current value that you would need to be multiplying by. So it's not B. You can also see those words plus and added in D, so it's probably going to be C, but let's just confirm. So C says 10% of the current values added to the account each year. Yes, because think about how you would get that. You would have to have like the initial amount, 1,000, and then you would multiply by 1.1. And actually, I just realized I put the word added so that you couldn't use that trick. So forget that I said that because I tried to make it extra annoying. I forgot about that. So 10% of the current value is added to the account each year. So think about how you would do that. You would start with the initial deposit of $1,000, and then you would have to multiply by, if it's increasing 10% each year, we're talking about 110%, so 1.1 as a decimal. And then each year when t is the number of years, so like if it's 2 years, then you're going to have to do 1.1 to the second power because you're going to have to multiply by 1.1 2 different times. So, and so on and so forth. So it's actually the current value that's changing rather than just adding on whatever 1.1 of 1,000 is each time, which is what B was essentially saying. Or B would have said like you're adding on what 0.1 of 1,000 is each time. So the answer is definitely C. Basically, for like linear versus exponential, for exponential, you have to imagine that you're multiplying by something, which can be like a decimal as well. So like some people get confused because they're like, but I'm taking a fourth of something, or I'm dividing by 4, but yes, that's technically the same as taking a fourth of something, like the same thing as multiplying by 1/4 or multiplying by 0.25. So like it's I like to think of it as multiplication, but I guess like technically it's kind of like division sometimes. But I just prefer like a one size fits all sort of method where I'm just going to be multiplying by something. It can be a decimal that's less than 1, which would be exponential decay in that case. But if I'm multiplying by something each time, it's exponential. And then if I'm adding or subtracting something each time, then it's going to be linear. Meaning like I'm adding or subtracting the same value on each time. Okay, so number 13, pause to read if you haven't already. So when they're saying the half-life of element Q is 15 minutes, it means you're multiplying by a half every 15 minutes for whatever the amount of time is, right? So we're starting with the initial of 40, and then we're multiplying by 1/2 every 15 minutes. And we're talking about the specific scenario where we want the mass at the same time tomorrow. So if it's the same time tomorrow, that means that 24 hours have passed. So think about, okay, if it's happening every 15 minutes, that means that every hour we have to multiply by it 4 different times, right? So every hour means multiplying by a half 4 different times. If there's 24 hours that we're talking about, then it has to be 4 times 24 as the exponent. So then that's just going to be 1/2 is the same thing as 0.5, so it would just be D right there. Okay, pause for number 14 if you haven't already. So you see here that as time increases, like as the years pass by, the value decreases, right? So it's definitely not going to be increasing or growth. So we're left to choose just between A and D. Now, we would know that this is linear. I think most students would find it easiest to kind of picture this as an XY table. And basically, it would be linear if you can find like a consistent slope. So you know that from like a table, probably in like 7th grade or something, you learned that like if you have an XY table, the slope is a change in Y over the change in X. So like the change here, how is it changing? Well, it's going down by 900, right? And then over here, it's going up by 4. Over here, is it going down by 900? No, but that can be okay with some of these if we can still get the same thing. If we can still get the same thing when we do whatever it decreases by over here to however it changes over here. So let's see. So 300 to 75 means it's going to be going down by 225. And then over here, 4 to 8, well, that's going up by 4. So there's no way that if we do the change in Y over the change in X, that we're going to get the same thing or a consistent slope for each of these. Because here it would be negative 900 over 4 for the slope. And over here it would be negative 225 over 4 for the slope. There's no way for those to be equal, so it definitely can't be linear. So it has to be exponential decay. Okay, pause for number 15. Okay, so all the initials should be 60,000 as we see here, because that's the current population that you have. And it says it's decreasing by 8% every year. So if it's decreasing by 8%, you have to think, okay, well, that means that we're keeping 92% because you have 100% currently, and then you're going to subtract 8% when you decrease by 8%, so you're left with 92%. So that means each year I should be finding 92% of the current, or each 15 years, sorry, I should be finding 92% of whatever the current population is. So how do I write 92% as a decimal? That would be 0.92. So that means what's in parentheses that I'm multiplying by each time definitely needs to be 0.92. So let's cancel out A and B. And now I have to remember, okay, but I'm only multiplying by 0.92 every 15 years. So when I look at the exponent, I have to make sure that that corresponds to what the exponent is saying. So it would be D because I would have the number of years being T, and then I have to divide that up into 15-year intervals. You can also think about like guessing and checking if you want, kind of like to see the logic behind the situation. For instance, I could say, oh, let me plug in for T, I'm going to say 15 years. So if it happens every 15 years and it's been 15 years, that means that I should only be multiplying by 0.92 one time, which if you plug in 15 there, 15 over 15 is 1, giving you 1 as the exponent, you only multiply by that one time. But if you plug in 15 for T here, it would be 15 times 15 as your exponent, so you're going to be multiplying by 0.92 that many times. So definitely not C, it has to be D. Okay, pause to read number 16 if you haven't already. So this is probably the easiest problem in this chapter because I just need to look at linear. When it's telling me it's linear growth in the question, there's only one option. It has to be A. That's the only one that's set up like y equals mx plus b format. B and C are exponentials, and D is a quadratic. So, A. Okay, pause to read number 17 if you haven't already. So, for this problem, you can memorize all, like I've said before, you can memorize all those parent functions if you want, and like how to graph, all that stuff. But remember, you have access to Desmos or like whatever approved calculator you want, that which includes graphing calculators that are approved. So you could literally just plug this in and see what matches. And if for some reason your calculator is not working on you, another much easier method than like trying to remember all the like stuff about graphing is just saying, oh, I could just make an XY table. So I could just plug in easy values for X. Like I'm going to plug in 0 for X there. If I plug in 0 for X, I should get, that's 2 to the 0, which means Y is equal to 1. So one of my points that should be plotted is 0, 1. I see that that happens for A. Let me see if it happens for any of the other ones. B, it's 0, -1, not 0, 1. So that's out. Again, same thing here. It's 0, -1. We don't want that. And then here it's 0, -3, so definitely not that one. So it is in fact A.